Here are a few application questions dealing with logarithmic functions. I would pause right here to take a moment to read over this question and then press play so we can go through this question together. So what we find is that we are given a function that relates the absolute magnitude, which is m, the uppercase M, the apparent magnitude, lowercase m, and the d, which is its distance from the Earth in parsecs. Okay, the rest of it is all numerical values, and so basically it relates those things. So notice I've put that function up here in the corner for you. If Sirius is 2.637 parsecs from Earth, so let's find for Sirius, and the Sun is 4.887 times 10 to the negative 6 parsecs from Earth, what's the absolute magnitude of each star? So given the information on the other screen, I had to go back and find the little m value, or the apparent magnitude, of both Sirius and the Sun. So we're going to use those values as well as, of course, our d values. So this would be distance and this would be distance, to find the absolute magnitude of Sirius. So the absolute magnitude would be negative 1.44 for my lowercase m minus 5 times the log of 2.637 divided by 10. Obviously, I'm going to utilize my calculator to find this answer. Again, if you're using a one-line calculator, divide this first, which of course is just going to move that decimal one place, because dividing by 10 would move the decimal. So I'm going to take log of 0.2637. I'm going to multiply that by 5 and then subtract it from negative 1.44. And when I did my calculations there, I found 1.454 would be m, which would be my absolute magnitude of Sirius. Now to find it for the Sun, I'm going to repeat that process. The apparent magnitude is negative 26.74. Everything else stays the same, but the distance is 4.887 times 10 to the negative 6 parsecs. Remember, that is a scientific value, so it's like 1, 2, 3, 4, 5, 6 places to the left. So that gives you an idea of that very, very small number. So 0.000004887 divided by 10. So basically one more zero added to the front of that. Go ahead and use your calculator to evaluate. So as we can see, the apparent magnitude of the Sun is 4.815 and the apparent magnitude of Sirius is 1.454. Here's an example for you to try on your own. So try the question, then press play to check your work. Here we're obviously dealing with the intensity of an earthquake using the Richter scale. And it's given us the logarithmic function already that we could use to find the intensity, I. So here it says determine the magnitude of an earthquake that is 10 to 5.2 times the I sub 0, and I sub 0 is our 0 level earthquake. So what I would do here to find the magnitude would be to find the log of I over I sub 0. So I would be, in this case, this is 10 to the 5.2 times I sub 0 over I sub 0. And so clearly we can see that those would cancel out. And so I'm finding the log of 10 to the 5.2. Now I can just plug this into my calculator. There is a property that will help us to make this a little bit easier. But for now, take 10 to the 5.2 and then take the log of that, and I end up with 5.2. Again, we've talked a little bit before about the fact that log base 10 and 10 would cancel, and so 5.2 would be my magnitude. I'll do the same thing for another earthquake that is 10 to the 4.2 times I sub 0. So my work is going to look similar, and it's 10 to the 4.2 times I sub 0 over I sub 0. And of course the I sub 0's cancel again, and I end up with 4.2. So the magnitude is 4.2. Now, how many times more intense is this earthquake than this earthquake? Well, that would be 10 to 5.2 times I sub 0 over 10 to the 4.2 times I sub 0, which canceling out would give me 10 to the 5.2 minus 4.2 using those properties of exponents that we learned so long ago, which gives me 10 to the first, or just 10. So it's 10 times more intense. 10 times more intense.